All right. Continue with NCERT exercise 7.3 integration, one of the most important topic, high weightage chapter for both board exams as well as competitive exams. We know that 7.3 deals with integration by using a trigonometric identities. You must be knowing all the trigonometric formulas of first PU. It may be trigonometric identities like Pythagorean identities, sine square theta plus cos square theta equal to 1 plus tan square theta equal to secant square theta, 1 plus cot square theta equal to cosecant square theta. Pythagorean identities, double angle formulae, triple angle formulae, half angle formulae, defactorization formulae, all these things are quite useful in this section. Okay, so use of trigonometric identities, the NCERT exercise 7.3 deals with. So we shall see what is integration by using a trigonometric identities. Okay, one by one we shall discuss. So integration by using trigonometric identities. Given an integral which involves a trigonometric function, what we do mainly is we make use of suitable trigonometric identities so that the given integral reduces to the standard form so that it is possible for us to integrate. That is what are given here. Okay, given an integral which contains a trigonometric function, we make use of suitable trigonometric identities. It may be Pythagorean identities or it may be double angle formula like sine 2 theta, 2 sine theta cos theta is equal to 2 tan theta by 1 plus tan square theta. Our main aim is to reduce the integral to the standard form. Okay, cos 2 theta, cos square theta minus sine square theta, 2 cos square theta minus 1, 1 minus 2 sine square theta, 1 minus tan square theta by 1 plus tan square theta, tan 2 theta, 2 tan theta by 1 minus tan square theta, sine 3 theta is 3 sine theta minus 4 sine cube theta, cos 3 theta, 4 cos cube theta minus 3 cos theta. Tan 3 theta is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Cos square theta, the power reducing formula we call, that's most important in this session. Cos square theta is 1 plus cos 2 theta by 2. Sin square theta is 1 minus cos 2 theta by 2. And also half angle formula, sin theta equal to 2 sin theta by 2 cos theta by 2 is equal to 2 tan theta by 2 divided by 1 plus tan square theta by 2. Cos theta equal to cos square theta by 2 minus sin square theta by 2 equal to 2 cos square theta by 2 minus 1 is also equal to 1 minus 2 sin square theta by 2 is also equal to 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2. Tan theta is equal to 2 tan theta by 2 divided by 1 minus tan square theta by 2. All these things are half angle formula. And 1 minus cos theta, 2 sin square theta by 2, 1 plus cos theta is 2 cos square theta by 2. All these formulas you have to learn properly. Okay. So if you're not learned of these formulas, please make a habit of learning all these formulas so that it becomes easy. Okay. Integration by using trigonometric identities. And also the defactorization formula, converting the product to sum, that's most important in this session. Sin A cos B, half sin A plus B plus sin A minus B. Cos A sin B is half sin A plus B minus sin A minus B. Cos A cos B equal to half cos A plus B plus cos A minus B. Lastly, we have sin A sin B equal to minus half into cos A plus B minus cos A minus B. All these formulas, please learn it, okay? So that this becomes easy. This exercise becomes easy if you learn all those formulas. And one important result we have here, one of the most important results in this. One of the most important result is this. Integral of f of ax plus b is capital F of ax plus b divided by coefficient of x plus a constant c, where capital F is the antiderivative of small f. This is quite useful in this session. Okay. You integrate a function, the terms inside the bracket is of the type ax plus b. A linear term is given, f of ax plus b. How to integrate a function of this type? Integral of f of ax plus b is given by this capital F. That means after integrating a function, say example sin 3x is given. To integrate sin 3x, what we get? Integral of sin is minus cos, we know. Integral of sin 3x will be minus cos 3x After integrating, what you do is divide by the coefficient of x. That's the formula here. Important result. Integral of f of ax plus b is capital F of ax plus b divided by coefficient of x. Coefficient of x is a plus a constant c. C is a constant of integral called as the arbitrary constant, which we add for every indefinite integral. I mentioned clearly that capital F is the antiderivative of small f. Antiderivative is nothing but the integral of the function. It is also called as a primitive of a function. Please make a note of this important result. Integral of f of ax plus b. After integrating, you get a new function, call it as capital F. Capital F is the antiderivative of small f. Okay, after integrating, you divide by the coefficient of x. Coefficient of x is a here in this case. So after integrating, you divide by coefficient of x, the most important thing. Okay, I'll take examples on this also to make you understand. Okay, so examples are given here. Integral of sine 7x. We know integral of sine is minus cos. So integral of sine 7x is minus cos 7x divided by coefficient of x. Coefficient of x is 7. So I'll write the answer here is equal to minus cos 7x. After integrating, you divide by coefficient of x. Coefficient of x is 7 plus a constant c. Integral of cos 2x. Integral of cos is sine. We know. Integral of cos 2x will be sine 2x divided by coefficient of x, that is 2. Correct? Sine 2x divided by coefficient of x 2 plus a constant c. Now again, integral of sine of 2x plus 3. Terms inside the bracket should be linear. Okay, then only it's applicable. Don't apply for quadratic or cubic and all. Terms inside the bracket should be linear term. That is, it should be of the type ax plus b only. Okay, 2x plus 3 is a linear function. It's a linear term. So integral of sine minus cos of 2x plus 3 minus cos of 2x plus 3 divided by the coefficient of x is 2. Correct? Plus a constant c. Integral of sine is minus cos of what is given, same thing here, right? Divided by coefficient of x. Here integral of cos of 2 minus 5x. Integral of cos is sine. So sine of 2 minus 5x. Sine of 2 minus 5x divided by coefficient of x, that is minus 5 plus a constant c. After integrating, divide by coefficient of x. Coefficient of x is minus 5. Integral of cos is sine. Sine of same thing here, right? Divided by coefficient of x, which is minus 5. Hope you understand. Next one, integral of e power 4x plus 3 with respect to x. Integral of e power x is e power x, correct? Integral of e power 4x plus 3 is e power 4x plus 3 divided by coefficient of x, that is 4. E power 4x plus 3 divided by coefficient of x, that is 4 plus a constant c. This takes the form integral of 1 by x. We know integral of 1 by x is log of mod x, correct? Integral of 1 by 2 minus 3x. 1 by x, instead of x given a linear term, 2 minus 3x. So it's applicable, the form, correct? So integral of 1 by x is log of mod x. Integral of 1 by 2 minus 3x. Log of mod 2 minus 3x divided by coefficient of x. Log of mod 2 minus 3x divided by coefficient of x, that is minus 3 plus a constant c. After integrating, you divide by coefficient of x. Coefficient of x happens to be minus 3 here. Okay, even the minus sign is important. Don't write just plus 3 here. You're dividing by coefficient of x. Coefficient of x is minus 3. Please make a note. Here, this takes the form integral of x cube. We know integral of x cube with respect to x is x power 4 divided by 4 plus c. Instead of x, what is given? A linear term, 5x minus 2. So to integrate this, what we get? 5x minus 2 to the power 4 divided by 4. This entire thing is divided by coefficient of x. Coefficient of x is 5 plus a constant c. Correct? If you only can write this as 5x minus 2 power 4 divided by 20. This 4 will come down. 4 into 5 becomes 20. Here, this takes the form integral of 1 by root x. We know integral of 1 by root x is 2 root x. Correct? Integral of 1 by root x is 2 root x. So this becomes 2 into root of 3x plus 4 divided by coefficient of x, that is 3, plus a constant c. After integrating, make a habit of dividing by coefficient of x. Okay, if it is linear term only. Next one, integral of 1 by 3x plus 5 the whole square. This takes the form integral of 1 by x square. Integral of 1 by x square is minus 1 by x. Likewise, integrate. Integral of 1 by 3x plus 5 the whole square will be minus 1 by 3x plus 5 divided by coefficient of x, which is 3. Correct? Integral of 1 by x square is minus 1 by x. So integral of 1 by 3x plus 5 the whole square is minus 1 by 3x plus 5, correct, divided by coefficient of x, that is 3, plus a constant. Integral of 1 by x square minus 1 by x. Integrate this as you integrate 1 by x square. Integral of 1 by x square is minus 1 by x. So integral of 1 by 3x plus 5 the whole square is minus 1 by 3x plus 5 divided by coefficient of x, that is 3. This takes the form integral of root x, root of linear term. Integral of root x we know 2 by 3 into x root x, or 2 by 3 into x power 3 by 2. Likewise, integrate. Integrate as if you integrate root x and divide it by coefficient of x. Correct? Integral of root x is 2 by 3 x power 3 by 2. Correct? So, same way I'll write 2 by 3 into 5x plus 7 to the power 3 by 2 divided by coefficient of x, which is 5, plus a constant c. Hope I understand. Integral of root x is 2 by 3 x power 3 by 2. Correct? Integral of root x. Root x means x power half. Integral of x power half is x power half plus 1 by half plus 1. Half plus 1 is 3 by 2. 1 by 3 by 2 is 2 by 3 root. Okay? So learn this formula, important. Integral of root x is 2 by 3 x root x. 2 by 3 x power 3 by 2. Both one and the same. So 2 by 3 5x plus 7 power 3 by 2 divided by coefficient of x is 5. Integral of a power x we know. This takes constant power variable. Constant power variable means it is a power x. Integral of a power x is what? A power x divided by log a. Correct? So integral of 10 to the power 7x plus 5 will be 10 to the power 7x plus 5 divided by log 10 divided by coefficient of x, which is 7. Okay, don't forget to divide by coefficient of x. So this is 10 to the power 7x plus 5 divided by log 10. I integrated using a power x formula. A power x divided by log a. This entire thing is divided by coefficient of x, that is 7, plus a constant c. This entire thing is divided by coefficient of x, which is 7. Now, lastly, we have integral of tan square. See, remember, to integrate tan square, we don't have a direct formula. Tan square and cot square is there. No, these two you should remember. We don't have direct formula. Whenever tan square is there, you should express it as secant square minus 1. Because you know the identity 1 plus tan square theta equal to secant square theta. So you should write tan square theta as secant square theta minus 1. Whenever tan square is there, you write secant square minus 1. And whenever there is cot square, you write cosecant square minus 1. Tan square of 5x minus 8, you can write it as secant square 5x minus 8 minus 1. Hope you understand. Tan square you write secant square minus 1. Cot square you write cosecant square minus 1. Hope you understand. Because we don't have a ready formula to integrate tan square x and cot square x. Of course, secant square x integral is tan x. Cosecant square integral is minus cot x. So we have a formula. That is why we need to convert tan square to secant square and cot square to cosecant square. Correct? So tan square, I'll write here itself, is equal to integral of tan square of 5x minus 8 is secant square of 5x minus 8 minus 1. Now we can integrate this. Integral of secant square is tan. Because derivative of tan is secant square. So integral of secant square is tan. So tan of 5x minus 8 divided by coefficient of x is 5. Correct? So this becomes tan of 5x minus 8, tan of 5x minus 8 divided by coefficient of x is 5. Correct? Integral of 1 is x minus x plus a constant c. Hope I understand. Integral of secant square is tan. Tan of 5x minus 8 divided by coefficient of x, that is 5. And integral of 1 is x. So minus 1, integral is minus x plus a constant c. Please make a note of this. I given many examples to understand this result. Okay. To understand this result, many examples were given. Hope I understood this. Move on to the next one. The trigonometric identities, what I told you. Just now I said trigonometric identities you have to learn. All these trigonometric formulas you have to learn. Okay. Please make a note of these formulas. If you have not known all these things, please learn it. Half angle formula and also the defactorization formula. Please learn all these things. We'll take up the problems now on this exercise 7.3 of NCERT book. Integral of cos 3x. Also I have given the solved examples connected to this topic. Okay, from the NCERT book. Included those questions as well. Integral of cos 3x. Integral of cos is sine. So this will be equal to sine 3x divided by coefficient of x, that is 3 plus a constant c. Cos 3x, integral of cos is sine 3x divided by coefficient of x. Coefficient of x is 3. So just a simple question. On to the next one. Integral of secant square 7 minus 4x. We know integral of secant square is tan. Correct? This becomes tan of, take the integral as I if you want. I is equal to integral of secant square of 7 minus 4x. We know integral of secant square x is tan x. So integral of secant square of 7 minus 4x is tan of 7 minus 4x. Tan of 7 minus 4x divided by coefficient of x. Coefficient of x is minus 4 plus a constant c. Integral of secant square is tan. Tan of 7 minus 4x divided by coefficient of x, which is minus 4. Don't write 7 then. Coefficient of x is not 7 then. Coefficient of x is not 4. Coefficient of x in fact is minus 4. Please take care of this. Move on to the next one. To integrate sine square x. Sine square x we can use the power reducing formula. Just now I told 1 minus cos 2x by 2. Sine square x. Take the integral as I. I is equal to integral of sine square x. Sine square x we can write it as 1 minus cos 2x divided by 2. 1 minus cos 2x divided by 2 using the power reducing formula. Divided by 2 means 1 by 2 can be kept outside. 1 by 2 keep outside. 1 by 2 is kept outside. Integral of 1 with respect to x is x. Integral of sine 2x, integral of cos 2x is sine 2x divided by coefficient of x. Coefficient of x is 2 plus a constant c. Sine square x, the power reducing formula. 1 minus cos 2x by 2 divided by 2 means keep 1 by 2 outside. Integral of 1 x. Integral of cos 2x is sine 2x divided by coefficient of x2. Suppose they ask to integrate cos square x, I'll write here. Integral of cos square x is required. Cos square x we can write it as 1 plus cos 2x by 2. If they ask how to integrate cos square x, you must know 1 plus cos 2x divided by 2. Cos square x formula, the power reducing formula. 1 plus cos 2x by 2 divided by 2 means keep 1 by 2 outside the integral. 1 by 2 is kept outside the integral. Correct? 1 by 2 keep outside. Correct? Divide by 2 means 1 by 2 keep outside. Integral of 1 is x. Integral of cos 2x is sine 2x divided by coefficient of x, that is 2 plus a constant c. On to the next one. Now integral of sine 2x into cos 3x. Here we use the defactorization formula as I told. Sine a cos b. Sine a cos b is half sine a plus b plus sine a minus b. Apply the transformation formula. Converting the product to sum is also called as defactorization formula. I'll write the formula here. Sine a cos b. Already shown the formula earlier in the slide. Also, I told to in the beginning itself I told these formulas, correct, orally. Sin A cos B is equal to half sin A plus B plus sin A minus B. Half sin A plus B plus sin A minus B. Correct? Sin A cos B formula. Half sin A plus B plus sin A minus B. Make use of this formula here. Sin A cos B. Take the integral as I. I is equal to integral of sin 2x into cos 3x dx. Sin A cos B. Sin A cos B. Half sin A plus B plus sin A minus B. Correct? So this is half into integral of sin of A plus B, right? Sin of 2x plus 3x plus sin of A minus B. Sin of 2x minus 3x. Sin A cos B formula. Half sin A plus B plus sin A minus B. This is equal to half into integral of, this becomes sin of 2x plus 3x is 5x plus 2x minus 3x is minus x. Sin of minus x. 2x plus 3x is 5x. 2x minus 3x is minus x. Sin of minus x is minus sin x. Correct? This is equal to half into integral of, this becomes sin 5x. Sin of minus theta is minus sin theta. Minus comes out. Correct? Minus sin x. So far I have not done the integration. Correct? At this stage I will do the integration. Half you keep as it is outside the integral. Integral of sin is minus cos. Minus cos 5x divided by coefficient of x 5. Integral of sin is minus cos. Minus of minus becomes plus there. Plus a constant c. Once the integration is complete, you can add a constant c. We add a constant c for every indefinite integral. Minus of minus will become plus there. You can write one more step. This is equal to half into minus of minus is plus. I'll write first cos x, then write minus cos 5x divided by 5 plus a constant c. Correct? 2x plus 3x is 5x. 2x minus 3x minus x. Sin of minus x minus sin x. Integral of sin is minus cos. Minus of minus plus cos x. Minus cos 5x divided by 5. Hope you understand this. Can be asked for 2 marks for board exams. Move on to the next one. Integral of sin cube x. There are 2 ways of doing this problem. Sin cube x, no, we can write it as sin square into sin. Then write sin square as 1 minus cos square x. That is one method. Another method is from sin 3x. Sin 3x we know 3 sin x minus 4 sin cube x. From there we should get an expression for sin cube x, then integrate. I will do both the methods, but first method is quite easy. Okay, take the integral as I. I is equal to integral of sin cube x. Sin cube x. Sin cube x could be written as sin square x into sin x. Then write sin square x equal to 1 minus cos square x. Sin square x is 1 minus cos square x into sin x dx. Okay, using the trigonometric identity, Pythagorean identity, sin square x equal to 1 minus cos square x. Now I'll put t equal to cos x. Derivative cos is minus sin. So sin x into dx will be minus dt. Correct? Put t equal to cos x. Put t is equal to cos x. Differentiate this. dt by dx. dt by dx. Derivative of cos x minus sin x. Or from this minus you take that side. Minus dt is equal to sin x into dx. Minus dt is equal to sin x into dx. Minus dt is equal to sin x into dx. So write everything in terms of t now. Sin x into dx is minus dt. So minus will keep outside. minus of integral of 1 minus t square, because I've taken cos x equal to t, 1 minus t square, sin x into dx is minus dt, minus kept outside, correct? This is equal to minus of integral of 1 with respect to t is t. Integral of t square is t cube divided by 3 plus a constant c. Integral of 1 with respect to t is t. Integral of t square is t cube divided by 3. Minus a multiply inside. Finally substitute back for t. This becomes minus into minus plus t cube divided by 3. Correct? Minus t plus c. T is what? Cos x. So we'll get the answer as cos cube x divided by 3 minus cos x plus c. This is one method. Okay. Another method of doing this problem is starting from sin 3x. We know the second method. I'll do here. Second method. Starting from sin 3x. What is sin 3x equal to? 3 sin x minus 4 sin cube x. From this, we can get an expression for sin cube x. Rearrange the terms. 4 sin cube x is equal to 3 sin x minus sin 3x. Correct? So, what do you get? 4 sin cube x is equal to 3 sin x minus sin 3x. Can divide by 4 throughout. I'll get sin cube x is equal to 3 sin x minus sin 3x divided by 4. Correct? 3 sin x minus sin 3x divided by 4. This 4 is brought to denominator. Now we can integrate this. Integral of sin cube x. Integral of sin cube x with respect to x. Divided by 4 means keep 1 by 4 outside. 1 by 4 keep outside. What is left? Integral of 3 sin x minus sin 3x. One by 4 into integral of 3 sin x is minus 3 cos x. Minus of minus becomes plus here, correct? Integral of sin 3x minus cos 3x divided by 3 plus a constant c. So what you get is 1 by 4 into minus 3 cos x, minus of minus becomes plus cos 3x divided by 3 plus c. Hope you understand this. The two ways of doing this problem, but first method is much better, easier compared to second. Second one is also easier, but first method is more comfortable. Correct? Starting from sin 3x, 3 sin x minus 4 sin cube x. Get 4 sin cube x, rearrange the terms. 4 sin cube x is 3 sin x minus sin 3x, or sin cube x is 3 sin x minus sin 3x divided by 4. Divided by 4 means keep 1 by 4 outside. Integrate 3 sin x. Integral of 3 sin x is minus 3 cos x. Integral of sin is minus cos. Integral of sin 3x minus cos 3x divided by coefficient of x3. Minus of minus plus. Get the answer like this. Answer looks to be different here, but we can prove both are same. If you apply cos 3x formula here, 4 cos cube x minus 3 cos x, and simplify, you will get the same answer. The constant term might be different, but the variable part will be same in both the cases. That is guaranteed. Okay. So, same way you can do cos cube x also. If they ask you to integrate cos cube x, there are two ways of doing. Cos cube x, you can write cos square into cos, then write cos square x as 1 minus sin square x, then put t equal to sin x. Okay, that is one way. Another way of doing the problem for integrating cos cube x is starting from cos 3x. Cos 3x is 4 cos cube x minus 3 cos x. From there you get an expression for cos cube x. Cos cube x will be cos 3x plus 3 cos x divided by 4. Correct? So you get an expression for cos cube x starting from cos 3x formula and then integrate. And after integrating, don't forget to divide by coefficient of x. That's the most important thing. Okay. Move on to the next one. Integral of sine square of 2x plus 5. Here I am using the power reducing formula. We know sine square theta. Sine square theta is equal to what? 1 minus cos 2 theta by 2. 1 minus cos 2 theta divided by 2. I'm using this. So take the integral as I here. I is equal to integral of sine square of 2x plus 5. Correct? Use this power reducing formula. Sine square theta is 1 minus cos 2 theta by 2. Theta becomes 2 theta. Angle gets double. Instead of theta, what we have? 2x plus 5. So if you are writing sine square 2x plus 5 here, sine square of 2x plus 5 is equal to 1 minus cos of double the angle. Theta becomes 2 theta, no? So 2x plus 5 double. Double means you multiply by 2 and write. Becomes what? 4x plus 10. 4x plus 10 divided by 2. Hope you understand how to write the power reducing formula. So this will be 1 minus cos of 4x plus 10. 2x double is 4x. Double of 5 is 10. Divided by 2. Divided by 2 means keep 1 by 2 outside. Divided by 2 means keep 1 by 2 outside. Integral of 1 with respect to x is x. Integral of cos is sine. Integral of cos is sine. Sine of 4x plus 10 divided by coefficient of x, that is 4, plus a constant c. Correct? Divide by 2 means keep 1 by 2 outside. Integral of 1 with respect to x, x. Integral of cos is sine. Sine of 4x plus 10 divided by coefficient of x, that is 4. Don't forget to divide by coefficient of x. Because of the linear term inside the bracket, you divide by coefficient of x. Hope I understand. What? Next one. Here, to integrate sine 3x into cos 4x. Again, we use the defactorization formula. Sine a cos b. Sine a cos b is equal to half sine a plus b plus sine a minus b. So, this is equal to, I'll take the integral as I here first. I is equal to integral of sine 3x into cos 4x. Sine a cos b is equal to half integral of sine of a plus b, correct? Sine of 3x plus 4x plus sine of 3x minus 4x. Half sine a plus b plus sine a minus b. This is equal to half into integral of what we get? Sine of 3x plus 4x, 7x. Sine of 3x minus 4x is minus x. This is equal to half into integral of, this is sine 7x plus into minus is minus, because sine of minus x is minus sine x, correct? Sine of minus theta is minus sine theta. Now we can integrate. Integral of sine is minus cos, correct? This is equal to half into integral of sine 7x is minus cos 7x divided by 7. Integral of sine is minus cos, minus of minus, direct, plus cos x, plus a constant c. Integral of sine is minus cos 7x divided by coefficient of x, 7. Integral of sine is minus cos, minus of minus plus cos x. Applying the product, converting the product to some formula. Defactorization formula is also called as sine a cos b, half sine a plus b plus sine a minus b. Integrate, get the answer. Sine of minus theta is minus sine theta. Cos of minus theta is cos theta. Sine of minus theta is minus sine theta. Move on to the next one. Question number 8. Here it's given as integral of cos 2x into cos 4x into cos 6x. What to do is, here we apply transformation formula for these two first. First, cos A cos B formula. Apply the transformation formula, converting the product to sum. Okay, cos A cos B is equal to half cos A plus B plus cos A minus B. Apply it, then multiply it, again apply the formula, transformation formula. Take the integral as I. Let I is equal to integral of cos 2x into cos 4x into cos 6x is equal to cos A cos B formula for this. For these two I am applying transformation formula, defactorization formula. Half into cos of A plus B, cos of A plus B, 2x plus 4x plus cos of A minus B, 2x minus 4x multiplied by cos 6x. Correct? This is equal to half into what we get. This is equal to half into integral of cos 6x plus cos of minus 2x into cos 6x. Correct? Multiply this. Cos of minus theta is cos theta. Cos of minus 2x will be cos 2x. This is cos 2x. Correct? This is nothing but cos 2x only. This is cos of minus 2x is equal to cos 2x. Now multiply this. What we get is equal to half into integral of cos 6x into cos 6x becomes cos square 6x. Here again multiply cos 2x into cos 6x. Correct? Here use the power reducing formula. What is power reducing formula? Cos square theta 1 plus cos 2 theta by 2. Apply the power reducing formula. Cos square theta is equal to 1 plus cos 2 theta divided by 2. Using this, cos square theta is equal to 1 plus cos 2 theta divided by 2. I am using this. So cos square 6x will be 1 plus cos 12x by 2. Here again apply defactorization formula. Cos A cos B half cos A plus B plus cos A minus B. So this is equal to 1 by 2 there itself will be there. Integral of this will be cos square 6x 1 plus cos 12x divided by 2. And here cos A cos B is half cos A plus B cos of 2x plus 6x becomes 8x. Correct? Plus cos of 2x minus 6x, that is minus 4x. We need to integrate this much. So far we are not done integration, correct? So far we are not done integration. I am simplifying it by using trigonometric formulas, correct? This 2 denominator and these 2 denominators, I'll take common denominator 2 and keep that 2 outside. 1 by 2 keep outside. 1 by 2 is already there. Another 1 by 2 will be kept outside. So 1 by 2 into 1 by 2 becomes 1 by 4. This is 1 by 4 into integral of what is left? 1 plus cos 12x. Correct? This 1 by 2 is kept outside, taken common and kept outside. What is left here is cos 8x, and cos of minus 4x is same as cos 4x. This is equal to 1 by 4 into integral of 1 is x. Integral of cos 12x is sin 12x divided by coefficient of x, that is 12. Integral of cos 12x sin 12x divided by coefficient of x is 12. Integral of cos 8x is sin 8x divided by coefficient of x, that is 8. Correct? Integral of cos 4x is sin 4x divided by coefficient of x, that is 4. Finally, add a constant c. Hope I understand this. Please make a note of this. Product of 3 cosine functions are given. Apply the defactorization formula for the first two. Cos A cos B half cos A plus B plus cos A minus B. 2x minus 4x is minus 2x. Cos of minus 2x is same as cos 2x. Multiply this. It cos square 6x plus cos 2x into cos 6x. Here use the defactorization formula at this stage. Correct? Cos square theta 1 plus cos 2 theta by 2. Again use the defactorization formula cos A cos B half cos A plus B plus cos A minus B. This formula is used. Cos A cos B is equal to cos A cos B is equal to half cos A plus B plus cos A minus B. You understand? Integral of cos is sine divided by coefficient of x after integrating. Okay, coefficient of x is 12. Here coefficient of x is 8. Coefficient of x is 4. Move on to the next one. Question number 9. To integrate sine cube 2x plus 1. Take the integral as I. Already I told how to integrate sine cube x. Same way we will integrate sine cube of 2x plus 1. Take the integral as I. Let I is equal to integral of sine cube of 2x plus 1. Sine cube x I told to integrate by using splitting that. Sine cube as sine square into sine. Same way do it here. Sine cube we write sine square into sine. Then write sine square as 1 minus cos square. Okay. Using trigonometric identity. This becomes sine square 2x plus 1. Sine square of 2x plus 1 into sine of 2x plus 1. Sine square theta is 1 minus cos square theta. So write this as 1 minus cos square of 2x plus 1. Correct? Sine square theta is 1 minus cos square theta into sine of 2x plus 1. Correct? To integrate this, I'll use the method of substitution because sine of 2x plus 1 into dx, I'll put t equal to cos of 2x plus 1. Put t is equal to cos of 2x plus 1. Also, there is a method that the power of sine is odd number, means you express put t equal to cos. The power of cos is odd number, means put t equal to sine. Here the power of sine is odd number, no? So you put t equal to cos. In terms of cos, you make a substitution. Okay, t equal to cos of 2x plus 1. Differentiate this. dt by dx. dt by dx. Derivative of cos is minus sine. Minus sine of 2x plus 1 into derivative of 2x plus 1, that is 2. Correct? Further differentiate 2x plus 1, that is 2. Derivative of cos is minus sine. Minus sine of 2x plus 1 into derivative of 2x plus 1, that is 2. So sine of 2x plus 1 dx, this will be dt by minus 2. Correct? From this dt by minus 2. dt by minus 2 will be equal to sine of 2x plus 1 into dx. Sine of 2x plus 1 dx is dt by minus 2. Keep minus 1 by 2 outside. Integral of this is 1 minus t square into dt. Correct? Sine of 2x plus 1 dx is minus dt by 2. Minus half kept outside dt. Integral of 1 is t. This becomes minus half into integral of 1 is t. Integral of 1 with respect to t is t. Integral of t square is t cube divided by 3 plus a constant c. Finally substitute back for t. T is cos of 2x plus 1. So minus half into t you substitute back. T is cos of 2x plus 1. Cos of 2x plus 1 minus cos cube of 2x plus 1 divided by 3 plus a constant c. Substitute back. T is cos of 2x plus 1. Okay. Minus half into cos of 2x plus 1 minus cos cube 2x plus 1 divided by 3 plus c. Hope you understand this. Sine cube is written as sine square into sine. Sine square I wrote 1 minus cos square. Remember the power of sine is odd number, means odd natural number. Put t in terms of cos. The power of cos is odd number. That in that case put t in terms of sine. This is a method. Okay. I'll explain all the methods of integrating trigonometric functions in synopsis part in detail. Okay. Also in the previous video also I explained how to integrate sine power mx into cos power nx, all those things. If both are odd, both are even, one is odd, other is even, correct? Different cases we discussed. Move on to the next one. Question number 10. Integral of sine cube x into cos cube x. Here both the powers of sine and cos are odd number. In that case, we can go for either substitution t equal to sine x or t equal to cos x. Any method will do. I'll take the integral as I here. I is equal to integral of sine cube x into cos cube x. I'll split this cos cube x as cos square into cos is equal to sine cube x into cos cube x, I'll write cos square x into cos x. Then write cos square x as 1 minus sine square x. Integral of sine cube x into cos square x is 1 minus sine square x into cos x dx. Correct? Writing cos square x as 1 minus sine square x. Now I'll put t equal to sine x. Method of substitution. So the derivative of sine x is cos x. Put t equal to sine x. Put t is equal to sine x. Differentiate this. dt by dx. Derivative of sine x is cos x. So dt equal to cos x into dx. dt is equal to cos x into dx. So this becomes integral of t cube into 1 minus t square into cos x into dx is dt. So this becomes integral of t cube into 1, that is t cube, minus t cube into t square becomes t power 5, open the bracket. Now we can integrate this. It is being reduced to the standard form. Integrating any function, always you have to reduce it to the standard form. Then only it's possible to integrate. So I reduce it to the standard form, correct? Integral of x power n form, x power n plus 1 by n plus 1. So integral of t cube is t power 4 by 4. This will be t power 4 divided by 4. Integral of t power 5 is t power 6 divided by 6 plus a constant c. Finally, substitute back for t. T is sin x. So I'll get the answer as sin power 4x divided by 4. Sin power 4x divided by 4 minus sin power 6x divided by 6 plus a constant c. Another way of doing this problem is I'll put t as I put t equal to sin x. No, I can go for substitution t equal to cos x also. In that case, I have to split sin cube x as sin square into sin. Second method also I'll do here. Second method. Answer looks to be different, but we can prove that they are same. Okay, they're equivalent. I is equal to integral of sin cube x, you write sin square into sin. Sin square x into cos cube x into sin x dx. Right, sin cube x as sin square into sin. And sin square x is 1 minus cos square x. Sin square x is 1 minus cos square x into cos cube x into sin x dx. Now you put t equal to cos x in this case. For this case, I'll put t is equal to cos x or u is equal to cos x. U is equal to cos x. So this implies du by dx. Derivative of cos x is minus sin x. So sin x into dx will be minus du. In terms of u, I'm writing here. Correct? So minus du is equal to sin x into dx. So this is equal to integral of 1 minus u square into u cube. Sin x into dx is minus du. Minus kept outside. Du. So this will be equal to what? Minus you multiply inside. Minus 1 into u cube. Correct? Minus into minus will be plus. Minus into minus plus u square into u cube is u power 5 minus 1 into u cube is minus u cube. Integrate this. Integral of u cube is u power 6 divided by 6. Integral of u cube with respect to is u power 4 divided by 4 plus c. What is u? Substitute back. U is cos x. Correct? So this will get cos power 6x divided by 6 minus cos power 4x divided by 4 plus a constant c. Here I am getting in terms of sine power 4x by 4 minus sine power 6 by 6. Here I am getting cos power 6x by 6 minus cos power 4x by 4 plus c. Answers looks to be different. Okay, if you differentiate this, we'll end up getting this only. If you differentiate this, you'll get this. That can be proved by using trigonometric formulas. Okay, so please make a note of this. I've done this problem by two different methods. Once by putting t equal to sin x and here by putting u equal to cos x. Derivative of cos is minus sine. Minus du equal to sin x into dx. Sin x into dx is minus du. Minus kept outside. Sin square x are 1 minus cos square x. Then u is cos x. No? So 1 minus u square into u cube. Minus 1 into u cube. Minus u cube. Minus into minus plus u square into u cube is u power 5. Correct? So then finally integrate and substitute back for u. Two different methods. Answers looks to be different but they are equivalent. If you differentiate this or differentiate this, you'll get the given integral. Move on to the next one. Integral of 1 by sine square x into cos square x. Here the important step is how to start the problem. So write 1 in terms of denominator. Denominator contains sine square and cos square. Sine square into cos square, right? So write 1 as sine square x plus cos square x. Okay. In this case, take the integral as I. I is equal to integral of 1 by sine square x into cos square x. Write 1 as sine square x plus cos square x. Expressing the numerator in terms of denominator. We know sine square x plus cos square x equal to 1, right? The fundamental trigonometric identity we know. Sine square x plus cos square x is equal to 1. So write 1 as sine square x plus cos square x. Write this numerator 1 as sine square plus cos square. Then separate the terms. 1 is sine square x plus cos square x divided by sine square x into cos square x. Separate the terms. Divide individually. Numerator is sum of two terms. It is of this type, a plus b by c. A plus b by c means what? We can write it as a by c plus b by c, right? Separate the term like this. A by c plus b by c. Separate the terms. Sine square x divided by sine square x cos square x plus cos square x divided by sine square x cos square x, so that it is possible to integrate. I am reducing it to the standard forms. Correct? Sine square x divided by sine square x into cos square x plus cos square x divided by sine square x into cos square x. Is equal to integral of sine square x will cancel, 1 by cos square x will get 1 by cos square x plus here cos square x will cancel, I get 1 by sine square x. This will be equal to integral of 1 by cos square x is secant square x, 1 by sine square x is cosecant square x. So far I have not integrated. At this stage I will integrate. Okay. Integral of secant square x is tan x. Integral of cosecant square x is minus cot x plus a constant c. Tan x minus cot x plus c. Reducing the given integral to the standard form and finally integrate. The first part is only simplification. Till here we simplified. Last step we are integrating it. Derivative of tan is secant square. So integral of secant square is tan. Integral of cosecant square is minus cot, because derivative of cot is minus cosecant square. So integral of cosecant square x is minus cot x. Finally add a constant c. For every indefinite integral we add a constant c. The constant called arbitrary constant to be added for every indefinite integral. Here again the defactorization formula sin a sin b. How to simplify sin a sin b, converting the product to sum. Sin A sin B is equal to minus half cos A plus B minus cos A minus B. Note the formula already I mentioned earlier, also is shown in the slide. Sin A sin B is equal to minus half cos A plus B minus cos A minus B. Use this and then integrate. Minus half cos A plus B minus cos A minus B. Sin A sin B is equal to minus half cos A plus B minus cos A minus B. Take the integral as I. Let I be equal to this. Let I is equal to integral of sin 4x into sin 8x. Sin A sin B. Sin A sin B is minus half cos A plus B minus cos A minus B. Minus half cos of A plus B 4x plus 8x minus cos of A minus B 4x minus 8x is equal to minus half into integral of, this becomes cos of 4x plus 8x is 12x, cos 12x minus cos of 4x minus 8x is minus 4x, cos of minus theta is cos theta, correct, is equal to minus half into integral of cos 12x, keep as it is, and here cos of minus theta is cos theta, cos of minus 4x is cos 4x, correct. Need to integrate this. Cos of minus 4x is cos 4x because cos of minus theta is cos theta, correct? Cos of minus theta is equal to cos theta. Sin of minus theta is minus sin theta, but cos of minus theta is cos theta, correct? So cos 12x minus cos 4x. Now at this stage I am integrating it. Minus half into integral of cos 12x is sin 12x divided by coefficient of x. Coefficient of x is 12. Integral of cos 4x is sin 4x divided by coefficient of x, that is 4. Finally, add a constant c for every indefinite integral. Integral of cos is sin. Integral of cos 12x, sin 12x divided by coefficient of x 12. Integral of cos 4x, sin 4x divided by coefficient of x 4. Minus half is constant kept as it is outside the integral. Okay. Sin A sin B formula, minus half cos A plus B minus cos A minus B, 4x minus 8x minus 4x, cos of minus 4x same as cos 4x. At this stage we can integrate after simplifying so much. Make use of this defactorization formula. Hope you understand. Move on to the next one. Question number 13. Integral of 1 minus cos x by 1 plus cos x. Here we make use of half angle formula. 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. Very simple question. It's an important one also. Asked in many exams. Integral of 1 minus cos x by 1 plus cos x. 1 minus cos x by 1 plus cos x is given. Make use of the half angle formula for this. 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. 2 cancels, correct? This becomes sin square by cos square, that is tan square. Tan square x by 2. Tan square x by 2. To integrate tan square, we don't have a direct formula. Whenever tan square comes, it should write it as secant square minus 1. 1 plus tan square is secant square. So tan square is secant square minus 1. So tan square x by 2, write it as secant square x by 2 minus 1. This is equal to integral of secant square x by 2 minus 1. And integral of secant square is tan. We know this. Integral of secant square is tan because derivative of tan is secant square. So integral of secant square is tan. Correct? Tan x, if we differentiate, we get secant square x. Derivative of tan x is secant square x. Derivative of tan x is secant square x. So So integral of secant square x is tan x. Secant square x by 2, integral of this is tan x by 2 divided by coefficient of x. Coefficient of x is 1 by 2. Correct? Don't write divide by 2, divide by 1 by 2. After integrating, I am dividing by coefficient of x. Coefficient of x happens to be 1 by 2 here. So divide by 1 by 2. And integral of 1 is x plus a constant c. And 1 by 2 becomes 2. So what we get is 2 tan x by 2 minus x plus c. Correct? 1 minus cos x, 2 sin square x by 2, half angle formula. 1 plus cos x, 2 cos square x by 2, 2 cancels. Sin square by cos square is tan square. To integrate tan square, we don't have direct formula. Whenever tan square comes, write secant square minus 1, so that it is possible for us to integrate. Integral of secant square x is tan x, but integral of secant square x by 2 is there. So tan x by 2 divided by coefficient of x 1 by 2. Integral of 1x, 1 by 2 becomes 2. So 2 tan x by 2 minus x plus c. Okay, hope I understand this. Move on to the next one. Integral of cos x by 1 plus cos x. Here what we do is, we can add 1 and subtract 1. There are two ways of doing this. You can multiply and divide by 1 minus cos x also. Because the denominator is 1 plus cos x, you can multiply and divide by 1 minus cos x. That is one method. Another method is, I'll express the numerator in terms of denominator. Denominator is 1 plus cos x, no? Numerator is cos x, no? So add 1, subtract 1 in the numerator. Then separate the terms. There are two ways of doing this problem. I is equal to integral of cos x by 1 plus cos x. Cos x by 1 plus cos x. Add 1, subtract 1 for this. In the numerator, add 1, subtract 1. 1 plus cos x minus 1 divided by 1 plus cos x. Correct? Then separate the terms. 1 plus cos x by 1 plus cos x minus 1 by 1 plus cos x. Separate the terms here. So this becomes equal to integral of 1 plus cos x divided by 1 plus cos x minus 1 by 1 plus cos x. This is equal to integral of 1 plus cos x will cancel, becomes 1 minus 1 by, what is 1 plus cos x? 2 cos square x by 2. 1 plus cos x is 2 cos square x by 2. Correct? Using the half angle formula. So this becomes is equal to integral of 1 minus 1 by 2, right? And 1 by cos square x is secant square. So secant square x by 2. So far we simplified. At this stage it is possible for us to integrate. Integral of 1 is x. Constant into variable means constant keep as it is. Integral of secant square is tan. Tan x by 2 divided by coefficient of x, which is 1 by 2. Correct? Divided by coefficient of x, that is 1 by 2 plus a constant c. This 2 will cancel. So what I get finally? X minus tan x by 2 plus c. X minus tan x by 2 plus a constant c. Add 1, subtract 1 in the numerator. Then separate the terms. 1 plus cos x by 1 plus cos x minus 1 by 1 plus cos x. 1 plus cos x by 1 plus cos x is 1. Integral of 1 with respect to x will be x. And here I am using half angle formula. 1 plus cos x is 2 cos square x by 2. So 1 by 2 into 1 by cos square. 1 by 2 I wrote as it is. 1 by cos square is secant square. So integral of 1 x. Half into secant square. Half you keep as it is. Integral of secant square is tan. Tan x by 2 divided by coefficient of x 1 by 2. 2 cancels. So you get x minus tan x by 2 plus c. Another method if you want I'll do. I can multiply and divide by 1 minus cos x and reduce it to the standard form. That method also we can try. The second method for your knowledge. Second method is I is equal to what we have? Integral of cos x by 1 plus cos x. Cos x by 1 plus cos x. Here we multiply and divide by 1 minus cos x. Multiply and divide by 1 minus cos x. So this is equal to what? Integral of this becomes cos x into 1 minus cos x. Denominator, I can multiply a plus b into a minus b, a square minus b square. It becomes 1 square, 1 minus cos square x. 1 minus cos square x is sin square x. Correct? This becomes integral of cos x into 1 minus cos x divided by sin square x. 1 minus cos square x is sin square x. Then we can separate the terms. I mean, cos by sin is cot and 1 by sin is cosec. I can write like this. This is sin square is sin into sin. I'll write cos by sin first. Cos by sin is cot x. Cos by sin x is cot x. Correct? And 1 by sin x, that is cosec x. Cosec x. Minus cos x by sin x is cot x. Like this I'll get. Then you can multiply this inside. Sin square I wrote, sin into sin. Cos by sin is cot. 1 minus cos by sin. There I am separating the terms and writing. 1 by sin is cosec. Cos by sin is cot. So now I can multiply it and integrate. Multiply this inside. Cot x into cosec x dx. Cot x into cosec x minus cot square x. Like this I get. This becomes a little bit complicated actually. But still I have done this for your knowledge. And you should write cot square x as cosecant square x minus 1 here. Cosecant square x minus 1. Then we should integrate. Correct? Integral of cot x into cosec x is minus cosec x. Correct? Minus integral of cosecant square. Integral of cosecant square is minus cot. Minus of minus becomes plus cot x. And here minus of minus becomes plus 1. Integral of 1 is x plus a constant c. Don't think that answers are different. Of course, we have the formula cot x minus cosec x. No, it is tan x by 2. We can prove. Cot x minus cosec x is minus tan x by 2. Because cosec x minus cot x is tan x by 2. Correct? This part is nothing but minus tan x by 2. Both are same. So answers are same. See, by using trigonometric formula, one can get the same answer. Even though the methods are different. This method is much easier compared to that. That is not so difficult, but still 2 steps extra it may be. That's the thing. Okay, multiply and divide by 1 minus cos x. If you learn different methods, you are improving your skills. That's why I'm doing it. Okay, so it will be helpful for competitive exams. The more skills if you have, it's good. So you can attack the problem. Any problem is given to you. Multiply and divide by 1 minus cos x. A plus b into a minus b, a square minus b square. 1 square is 1 only. 1 minus cos square x is sin square x. Then multiply this inside. Separate the terms. Sin square is sin into sin. Correct? Cos by sin is cot. 1 minus cos by sin is written as cosec x minus cot x. Hope you understand. 1 minus cos x by sin x. 1 minus cos x by sin x I wrote. Like this. 1 minus cos x by sin x. That is 1 by sin x cosec x. Cos by sin is cot x. Multiply inside. Cot square x we can't integrate directly. Tan square and cot square, two things. Remember, tan square comes means you write secant square minus 1. Cot square comes means you write cosecant square minus 1. Then only it's possible to integrate. Hope you understand. Move on to the next one. Integral of sine power 4x. So power of sine is even number means we make use of the power reducing formula. Power of sine is odd number, I told. If sine cube x is given, you put t equal to cos x. If cos cube x is given, put t equal to sin x and integrate. Of course, sine cube x is split as sine square into sine and write sine square as 1 minus cos square. Cos cube x is given means you write cos square into cos and write cos square as 1 minus sine square. Sine power 4x is given, we make use of the power reducing formula. Sine square x the whole square, right? Sine square x is 1 minus cos 2x by 2. Okay, take the integral as I. Learn all the methods of integration, it's quite important. I is equal to integral of sine power 4x. I is equal to integral of sine power 4x. This you can write it as sine square x the whole square. Sine square x the whole square. Sine square x is equal to 1 minus cos 2x by 2. Sine square x formula. 1 minus cos 2x divided by 2. The whole square. Using the power reducing formula. Sine square x is 1 minus cos 2x by 2. Okay. A minus b whole square formula I can use. A square plus b square minus 2ab. Denominator is 2. No, 2 square is 4. Keep 1 by 4 outside the integral. This becomes 1 by 4. 2 square is 4. Denominator is 4 means multiplied by 1 by 4. Which is kept outside the integral. So what is left? Integral of This is a minus b whole square formula I should apply and simplify it. Again I should apply the power reducing formula, then we can integrate. This is 1 by 4 into integral of a minus b whole square formula, a square 1 square 1 plus cos square 2x, correct, minus 2ab minus 2 into cos 2x. So much I need to integrate. So this is equal to 1 by 4 into integral of, this is 1 plus cos square 2x is what? 1 plus cos 4x divided by 2 minus 2 into cos 2x. I am using the power reducing formula. So far I have not done integration. Just I am applying the formulas and simplifying. Algebraic identity is applied, a minus b whole square, and the power reducing formula I applied. I wrote sine power 4x as sine square square. Sine square x is 1 minus cos 2x by 2. Correct, the whole square. Denominator is 2. 2 square is 4. Keep outside. A minus b whole square formula. A square plus b square minus 2ab. Cos square 2x is 1 plus cos 4x by 2. Again use the power reducing formula here. Here you separate the terms. 1 by 2 plus cos 4x by 2. Separate the terms. Simplify one more step and finally integrate. So I'll continue here. I is equal to what we have 1 by 4. Keep outside only. What we have integral of. This will be equal to 1 plus 1 by 2 plus cos 4x by 2. Correct? 1 by 2 plus cos 4x by 2 means 1 by 2 cos 4x. 1 by 2 cos 4x minus 2 cos 2x. This much I need to integrate. One more step on it. 1 by half plus 1 is 1 and half. Sum of these two. 1 plus half, 1 and half. 1 and half is 3 by 2, correct? So this becomes 1 by 4 into integral of what we have is 3 by 2 plus 1 by 2 into cos 4x minus 2 into cos 2x. So far we have not done the integration. At this stage I'll integrate and complete it. Okay. This is equal to 1 by 4 into integral of constant is constant into x. Integral of 3 by 2 is 3 by 2x plus 1 by 2 into integral of cos 4x is sin 4x divided by coefficient of x is 4 minus 2 into integral of cos 2x is sin 2x divided by coefficient of x is 2 plus a constant c. 2 cancels. Correct? So I can write the answer finally 1 by 4 into what we have 3x divided by 2 plus sin 4x divided by 8 sin 4x divided by 4 into 2 8 minus sin 2x. Hope you understand. Please make a note. Practice all the problems of NCERT exercise. It's important. Applying a minus b whole square formula. I wrote sin power 4x as sin square x the whole square. Sin square x is 1 minus cos 2x by 2. Denominator is 2. 2 square is 4. Kept outside 1 by 4. Divided by 4 means 1 by 4. A minus b whole square formula. A square plus b square minus 2ab. Again apply power reducing formula here. Cos square 2x is 1 plus cos 4x by 2. Separate the terms. 1 by 2 plus cos 4x by 2. 1 by 2 plus half cos 4x. Cos 4x by 2 means half into cos 4x. 1 plus half, 1 and half. 1 and half is 3 by 2. Half cos 4x minus 2 cos 2x. Integral of 3 by 2 is 3 by 2x. Integral of cos 4x is sin 4x by 4. Half is kept as it is. Correct? Here half into cos 4x. Constant into variable. Constant keep as it is. Integral of cos 4x. Integral of cos 4x is sin 4x divided by 4. Constant into variable. Constant keep as it is. Integral of cos 2x sin 2x by 2. 2 cancels. Keep the answer in this form. Okay. Move on to the next one. Integral of cos power 4 to x. Take the integral as I. Can you try this? Cos power 4 to x. You can write cos square 2x the whole square. Similar to sin power 4x. But here the angle is 2x here. That's a difference. Almost same as the previous one. Cos power 4 to x. You can write it as cos square 2x the whole square. Use the power reducing formula for cos square 2x. 1 plus cos 4x by 2 whole square. Correct? Expand it. Simplify. Again use power reducing formula. Then integrate. Get the answer. Can you try this? Take the integral as I is equal to, let I is equal to integral of cos power 4 to x dx. I'll write this as cos square 2x the whole square. Cos square 2x the whole square. This is equal to integral of cos square 2x is what? 1 plus cos 4x divided by 2 the whole square. Cos square 2x, 1 plus cos 4x by 2. Denominator 2 square means 4, keep outside. Divided by 4 means 1 by 4 outside. Is equal to 1 by 4. What is the integral of 1 plus cos 4x the whole square? Expand it. A plus b whole square formula. A square plus b square plus 2ab. Integral of 1 square is 1 plus cos 4x square, that is cos square 4x plus 2ab, 2 into 1 into cos 4x, 2 cos 4x. Again use the power reducing formula for this. Cos square 4x is 1 plus cos 8x by 2. Use the power reducing formula for this. This is equal to 1 by 4 into integral of, this becomes 1 plus cos square 4x is 1 plus cos 8x by 2. Correct? Using the power reducing formula, plus 2 times cos 4x. Correct? Cos square 4x is 1 plus cos 8x by 2. Hope you understand. Cos square 2x the whole square root, cos power 4x. Cos square 2x, write the power reducing formula, 1 plus cos 4x by 2. Because cos square theta is 1 plus cos 2 theta by 2. Denominator is 2, 2 square 4, keep 1 by 4 outside. A plus b whole square formula, a square plus b square plus 2ab, 2 into cos 4x into 1, 2 cos 4x. Cos square 4x is 1 plus cos 8x by 2. Separate the terms there. Therefore, I is equal to what we have? 1 by 4 is there. 1 by 4 integral of what we have? 1 plus 1 by 2. Separate the terms. 1 by 2 plus cos 8x by 2. Cos 8x by 2 is half into cos 8x. Half into cos 8x. Correct? Plus 2 times cos 4x. This is equal to 1 by 4 into 1 plus half, 1 and half, that is 3 by 2. Integral of 3 by 2 is 3 by 2x. Correct? Integral of 3 by 2 is 3 by 2x. Here 1 by 2 into integral of cos 8x is sin 8x divided by coefficient of x, that is 8, plus 2 into integral of cos 4x is sin 4x divided by coefficient of x, that is 4, plus a constant c. This is equal to 1 by 4 into what we have. This is equal to 3x divided by 2 plus sin 8x divided by 16. Correct? 8 into 2 16, plus here 1 2 will cancel, 2 2s are 2 1s are 2 2s are, so I'm getting sin 4x divided by 2. Hope you understand this. 1 plus half, 1 and half, 3 by 2. Integral of 3 by 2 is 3 by 2x. Constant into variable. Constant keep as is. Integral of cos 8x, sin 8x divided by coefficient of x, 8. 2 into cos 4x. 2 you keep as it is. Integral of cos 4x is sin 4x divided by coefficient of x, 4. 2 1s are 2, 2s are cancels. Sin 4x by 2. Here 2 into 8 is 16. 3x by 2 keep as it is. This is the answer. Hope you understand. Please practice all these problems. Move on to the next one. Question number 17. Take the integral as I. This is quite easy actually. This question appeared in KCET 2015 also. Same question. Sin square x, I'll write it as 1 minus cos square x. Because denominator is 1 plus cos x. No? So I'll write sin square x as 1 minus cos square x. Using the Pythagorean identity. Let I is equal to integral of sin square x divided by 1 plus cos x. Sin square x is 1 minus cos square x. Sin square x is 1 minus cos square x divided by 1 plus cos x. Writing sin square x as 1 minus cos square x. 1 is same as 1 square, correct? 1 is same as 1 square. So I can write this in the form of a square minus b square, which is a plus b into a minus b. 1 plus cos x into 1 minus cos x. Denominator is 1 plus cos x. 1 plus cos x will cancel, assuming that 1 plus cos x is not equal to 0. So that 1 plus cos x has been cancelled. So what is left? Integral of 1 minus cos x. Integral of 1 is x. Integral of 1 with respect to x is x. Integral of cos x is sin x. So x minus sin x plus c. On to the next one. Integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha with respect to x. Here alpha is a constant. Please make a note. Alpha is a constant. So cos 2 alpha as well as cos alpha both are constants. X is a variable because dx is present. No, the variable for integral is x. So take the integral as I, which will simplify this. Let I is equal to integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha. Even this question appeared twice in the CET exam, I think. They asked instead of alpha, it was given theta. Okay, the symbol was theta instead of alpha. Cos 2x minus cos 2 theta by cos x minus cos theta with respect to x. That was a question asked 2 times in CET exam. Okay, I think in the year 2021 and 2017. Not very sure. Might be 2021 and 2017. Okay. So now to simplify this, we shall apply the formula for cos 2x and cos 2 alpha. Cos 2x has various formula. There are 4 of them, correct? Cos 2x could be written as cos square x minus sin square x. 2 cos square x minus 1. 1 minus 2 sin square x is also equal to 1 minus tan square x by 1 plus tan square x. The suitable formula for cos 2x in this case is, I'll write 2 cos square x minus 1. I'll express cos 2x purely in terms of cos because the denominator contains cos, right? Denominator is cos x minus cos alpha. So I'll express cos 2x and cos 2 alpha in the numerator in terms of cos alone. Okay, cos alone. So this becomes integral of cos 2x, I'll write 2 cos square x minus 1. Cos 2x is 2 cos square x minus 1. Cos 2 alpha is 2 cos square alpha minus 1 divided by cos x minus cos alpha. Simplify this is equal to integral of 2 cos square x minus 1, open this bracket, minus 2 cos square alpha, minus into minus becomes plus 1 divided by cos x minus cos alpha. Minus 1 plus 1 cancels. Minus 1 plus 1 will add up to 0. Correct? This becomes 2 common here. Minus 1 plus 1 will add up to 0. 2 is common there. What remains? Cos square x minus cos square alpha divided by cos x minus cos alpha. And numerator takes the form a square minus b square. What is a square minus b square? A plus b into a minus b. So this integral I is equal to 2 into integral of a square minus b square, a plus b into a minus b, cos x minus cos alpha into cos x plus cos alpha. Divided by cos x minus cos alpha with respect to x. Cos x minus cos alpha will cancel. So what is that? 2 into integral of cos x is sin x. Correct? And cos alpha is constant here. Don't write integral of cos alpha is sin alpha. Alpha being a constant, cos alpha is a constant. Integral of constant is constant into x because I am integrating with respect to x. Integral of cos alpha is cos alpha into x plus a constant c. Hope you understand. Go on, simplify it. Integral of cos x is sin x. Integral of cos alpha is cos alpha into x. Correct. Move on to the next one. Question number 19. Integral of cos x minus sin x by 1 plus sin 2x. The method of simplifying this is, I'll write 1 plus sin 2x as sin 2x, we know the formula, 2 sin x cos x, double angle formula, and I'll write 1 as sin square x plus cos square x, and I can complete the square there. A square plus b square plus 2ab form, which is a plus b the whole square, correct? Write 1 as sin square x plus cos square x. Sin 2x is 2 sin x cos x. Let I is equal to integral of cos x minus sin x divided by 1 plus sin 2x is equal to integral of what we have, cos x minus sin x. Numerator keep as it is. Denominator I'll write 1 as sin square x plus cos square x, and sin 2x is 2 sin x cos x, a double angle formula, 2 sin x cos x. Denominator takes the form a square plus b square plus 2ab, which is a plus b the whole square, correct? Numerator is keep as it is, cos x minus sin x divided by denominator is a square plus b square plus 2ab, which is a plus b the whole square, sin x plus cos x the whole square. Now to integrate this, I'll use method of substitution. Put t equal to sin x plus cos x, because the derivative of sin plus cos is cos minus sin. If you differentiate sin x plus cos x, I'll get the numerator. So I'll use the method of substitution. Put t is equal to sin x plus cos x. Put t is equal to sin x plus cos x. Differentiate this. dt by dx. dt by dx. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Correct? So from this, dt is equal to cos x minus sin x into dx. Correct? Derivative of sin is cos. Derivative of cos is minus sin. Cross multiply. So cos x minus sin x into dx. Numerator is dt. Numerator is dt. Denominator is t square. Integral of dt by t square is minus 1 by t. Means integral of 1 by t square. dt means 1 dt. Integral of 1 by t square with respect to t is minus 1 by t. So this is equal to minus 1 by t plus a constant c. That's equal to minus 1 by, what is the t you substitute by? T is sin x plus cos x. Integral of 1 by t square is minus 1 by t. T you substitute by, t is sin x plus cos x. So answer is minus 1 by sin x plus cos x. Simple question. Writing 1 as sin square x plus cos square x. Sin 2x is 2 sin x cos x. So that I can complete the square. A square plus b square plus 2ab is a plus b the whole square. Then use method of substitution. Put t equal to sin x plus cos x. If you differentiate sin x plus cos x, I get cos x minus sin x. Numerator can be derived from sin x plus cos x, correct? So dt by t square. Integral of 1 by t square is minus 1 by t. Finally substitute back for t. Finally also add a constant c for every indefinite integral. Move on to the next one. Question number 20. Integral of tan cube 2x into secant 2x dx. Take the integral as I. Let I is equal to integral of tan cube 2x into secant 2x dx. What we'll do here is, see, derivative of tan is secant square, correct? But secant square is not there. And derivative of secant x is secant x tan x, Correct? That idea I'm going to use. See, derivative of tan x is secant square x. Tan 2x is present, but secant square 2x is not there in the question. Correct? Derivative of tan 2x will be secant square 2x into 2. Secant square 2x is not found in the given integral. So I don't use the substitution for t equal to tan 2x. Whereas if you put t is equal to secant 2x, I can write on what is derivative of secant 2x? Secant 2x into tan 2x into 2. That idea I'm going to use. I'm going to use the substitution t equal to secant 2x. Not directly. I have to manipulate a bit because it's not found exactly, correct? So tan cube 2x I'll write tan square into tan. Tan square, you write secant square minus 1. That's the idea. Then you can put t equal to secant 2x as I told. So what we'll do here is this is equal to integral of tan cube 2x. I shall write it as tan square 2x into tan 2x. Tan cube 2x is tan square 2x into tan 2x into secant 2x dx. Tan cube is tan square into tan. Now write tan square 2x as secant square 2x minus 1. Correct? This is equal to integral of secant square 2x minus 1. This much. Into tan 2x into secant 2x dx. Correct? Writing tan square as secant square minus 1. Correct? Tan square is secant square minus 1. This you keep as it is. Now use the method of substitution for this. Put t is equal to secant 2x. Put t is equal to secant 2x. Differentiate this. dt by dx. dt by dx. Derivative of secant 2x is secant 2x into tan 2x into derivative of 2x, that is 2. Correct? Into 2. So secant 2x into tan 2x dx will be dt by 2 from this. Correct? From this dt by 2 is equal to secant 2x into tan 2x into dx. Correct? This part will be dt by 2. dt by 2 means 1 by 2 keep outside. 1 by 2 keep outside. So what is left is integral of secant 2x is t. So this becomes t square minus 1. This part is dt by 2. dt by 2 means half dt. Half is kept outside the integral. This part is dt, alright. Now we can integrate. It has been reduced to the standard form. Integral of t square is t cube divided by 3. Integral of 1 with respect to t is t plus a constant c. Finally, substitute back for t. T is secant 2x. Correct? So answer is 1 by 2 into, put t equal to secant 2x back. Secant cube 2x divided by 3 minus t is secant 2x plus a constant c. Hope you understood this. Tan cube, right? Tan square into tan. Tan square is secant square minus 1. Then put t equal to secant 2x. Derivative of secant 2x is secant 2x tan 2x into 2. So secant 2x into tan 2x is a dt by 2. So 1 by 2 kept outside. This becomes t square minus 1. Half into integral of t square is t cube by 3. Integral of 1 with respect to t is t. Finally substitute back for t. T is secant 2x. Half is kept outside the integral. It's a constant. Constant into variable. Constant keep as it is. Integrate the variable. Hope I understand this. Move on to the next one. Question number 21. To integrate tan power 4x, take the integral as I. Tan power 4x and cot power 4x are similar type. Learn the methods, okay? And tan cube x also I can teach. It's not there in the NCERT book, I think. Tan cube x also I shall do after this. Take the integral as I. Let I is equal to integral of tan power 4x. Tan power 4x we shall write it as tan square x into tan square x. Tan square x into tan square x. One tan square x you keep as it is. Another tan square x you write secant square minus 1. This is all right. Secant square minus 1 into tan square x dx. Then multiply this inside. So what we get is equal to integral of secant square x into tan square x minus tan square x dx. Correct? Tan square x, right? Secant square x minus 1. Multiply this inside. Secant square x into tan square x minus tan square x. To integrate the first term, no, we can use method of substitution. Put t equal to tan x. Derivative of tan x is secant square x. I can reduce it to the standard form by using the method of substitution. And to integrate tan square x, we know always tan square x comes means you write secant square minus 1. For this, use method of substitution. For this, use tan square x equal to secant square x minus 1. So whenever you get tan power 4x, you write tan square into tan square. One tan square x you keep as it is. Another tan square x you write secant square minus 1. Okay. Now you put u is equal to tan x or t equal to tan x, whatever. Put u is equal to tan x, the first integral. Put u is equal to tan x. From this du by dx. Du by dx is equal to derivative of tan x is secant square x. So du is equal to secant square x into dx. Du is equal to secant square x into dx. So secant square x, I can multiply this inside. This is equal to integral of secant square x into tan square x into dx minus integral of tan square x. So this is equal to integral of, for this integral I have taken u equal to tan x. This becomes u square. This is u, correct? U square. Secant square x into dx is du. Integral of u square du. That means integral of u square with respect to u. For tan square x you write secant square x minus 1. Tan square x you write secant square minus 1. Integral of u square is u cube divided by 3. And integral of secant square x is tan x. Integral of 1 is x. Finally add a constant c. And substitute back for u. Finally u is tan x. No, this becomes tan cube x divided by 3. Tan cube x divided by 3 minus tan x minus of minus plus x plus a constant c. Understood? Take u equal to tan x. Derivative of tan is secant square x. Secant square x into dx is du. Integral of u square is u cube by 3. Integral of secant square x is tan x. Integral of 1x. Write tan square x as secant square x minus 1. Same way you can try integral of cot power 4x also. Cot power 4x you can write cot square into cot square. One cot square x keep as it is. Another cot square x you can write it as cosecant square x minus 1. Then open the bracket. First integral can be done by substitution, putting t equal to cot x. And second integral is integral of cot square x. You can write cosecant square x minus 1. Try that. Okay. Integral of cot power 4x. Similar to this. And if you want integral of tan cube x. Okay, tan cube x if you want, I'll show you. Tan cube x could be written as tan square into tan. Suppose you want to integrate tan cube x. Tan cube x if you want, I can write it as tan square x into tan x. Tan square x into tan x. Then write tan square x as secant square x minus 1. Secant square x minus 1. Into tan x. Correct? Write tan square x as secant square x minus 1. Then multiply this inside. This becomes secant square x into tan x dx minus integral of tan x. Like this we'll get. And the first one can be done by method of substitution because derivative of tan is secant square. And the second one, integral of tan x we know, log of mod secant x plus c. Correct? Integral of tan x. For this, again use the substitution. Take u equal to tan x. This becomes u. And this is secant square x into dx will be du. Correct? This becomes equal to what we get, integral of u with respect to u minus integral of tan x is log of mod secant x. That I'll write in the next step. This will be u square by 2. Integral of u with respect to u because u is tan x. U is tan x. Derivative of tan x is secant square x. Integral of u is u square by 2. What is u? U is tan x. So tan square x by 2. Tan square x divided by 2 minus integral of tan x is log of mod secant x. Log of mod secant x plus a constant c. Same way you can try cot cube x also. Integral of cot cube x. Cot cube x you can write cot square into cot. Cot square you write cosecant square minus 1. Then open the bracket. First integral by substitution. And integral of cot x is second term. Integral of cot x is log of mod sin x. Hope you understand. Please practice. If you're preparing for competitive exams, you should learn all the different integrals, different types. Not only just NCERT, you have to go beyond NCERT, especially for JEE exams. Okay, tan power 4x means you should know how to integrate tan cube x, tan power 5x, tan power 6x. All you should learn. Okay, that analyze all the different problems. How to start the problem at least you must know. Okay, that's the most important. Next one, integral of sine cube x plus cos cube x divided by sine square x into cos square x. Here you can separate the terms. Numerator is sum of two terms, no? Separate the terms, divide individually. Sine cube x by sine square x cos square x plus cos cube x by sine square x cos square x. Separate the terms and then integrate. Let I is equal to integral of sine cube x plus cos cube x divided by sine square x into cos square x. Separate the terms. What we get? Separating the terms, this becomes integral of sine cube x divided by sine square x into cos square x plus integral of cos cube x divided by sine square x into cos square x. Is equal to integral of, here sine square x will cancel, correct? One sign remains in the numerator. So this becomes sine x divided by cos square x means cos x into cos x plus integral of, here cos square x will cancel, get cos x divided by sine square x is sin x into sin x, and sin by cos is tan, into 1 I can consider, sin by cos is tan, 1 by cos is sec, into 1 you consider, sin x means sin x into 1, so sin by cos is tan, 1 by cos is sec. This will be equal to integral of tan x into secant x, tan x into secant x with respect to x. Here this is cos by sin is cot, into 1 you can consider, so 1 by sin is cosec. Integral of tan x into secant x is secant x. Integral of cot x into cosec x is minus cosec x plus a constant c. Correct? Derivative of secant x is secant x tan x. So integral of tan x secant x is secant x. Derivative of cosec x is minus cosec x cot x. So integral of cot x cosec x is minus cosec x. So we'll end up with secant x minus cosec x plus c. Just separate the terms, divide individually. Sin square x will cancel, sin by cos square, sin by cos square, sin by cos into cos, sin by cos tan, 1 by cos sec, cos cube x by sin square x into cos square x, cos square x will cancel, 1 cos remains, cos by sin is cot, 1 by sin is cosec, integral of cot x into cosec x is minus cosec x plus a constant c finally. Move on to the next one. Integral of cos 2x plus 2 sin square x divided by cos square x. Our main aim is to reduce the integral to the standard form. So for that what we do is, we write the formula for cos 2x in terms of sine. Because in the numerator you can see 2 sin square x. Cos 2x there are various formulas. Cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 1 minus tan square x by 1 plus tan square x. The suitable formula to simplify this is 1 minus 2 sin square x. Take the integral as I. Let I is equal to integral of cos 2x plus 2 sin square x divided by cos square x. Right, cos 2x is 1 minus 2 sin square x. Cos 2x is 1 minus 2 sin square x plus 2 sin square x divided by cos square x. Writing cos 2x as 1 minus 2 sin square x, so that these two will add up to 0. minus 2 sine square x plus 2 sine square x add up to 0. What is left is, this becomes 1 by cos square x. 1 by cos square x is secant square x. Integral of secant square x is tan x. So this becomes tan x plus a constant c. 1 by cos square x is secant square x. Integral of secant square x is tan x. Tan x plus c. Next one, to integrate 1 by sin x into cos cube x. Our main aim is to reduce the integral to the standard form. To reduce it to standard form, sometimes it use some skills. Then only it's possible. Some problems are straightforward. Some problems are not so straightforward. In that case, you do some adjustment. Here, to reduce it to standard form, what I shall do is, in the denominator, I'll multiply and divide by cos x. Take the integral as I. Let I is equal to integral of 1 by sin x into cos cube x. In the denominator, you multiply and divide by cos x. 1 by, here it is sin x is there, divide by cos x and multiply by cos x in the denominator. Cos cube x into cos x. Multiply and divide by cos x. Multiply and divide by cos x. Sin by cos is tan. Sin by cos is tan. Correct? Cos cube into cos becomes cos power 4. Cos power 4, take it up. What I did in the denominator, multiply and divide by cos x in the denominator. Sin by cos is tan. Cos cube into cos becomes cos power 4x. And 1 by cos power 4x is secant power 4x. So this becomes equal to integral of, this I'll take it to numerator, we get secant power 4x divided by sin x by cos x is tan x. Then write secant power 4 as secant square into secant square. Split this. Secant square x into secant square x divided by tan x. And you know the derivative of tan x is secant square x. One secant square x you keep as it is. Another secant square x you write it as 1 plus tan square x. So I becomes equal to, I is equal to integral of 1 secant square x, I'll write it as 1 plus tan square x. Another secant square x you keep as it is. Another secant square x you keep as it is. Correct? Divided by tan x. Since you know the derivative of tan x is secant square x, I can make a substitution for u equal to tan x. Let u is equal to tan x or t is equal to tan x, whatever. Let u is equal to tan x. Differentiate this. Du by dx. Derivative of tan x is secant square x. So du is equal to secant square x into dx. Du is equal to secant square x into dx. So this becomes equal to 1 plus, what is tan x? U. So 1 plus u square. Correct? Secant square x into dx is du divided by tan x is u. Separate the terms, is equal to 1 by u plus u square by u. U square by u is u. Separating the terms like this. Correct? Separate the terms. 1 by u plus u square by u. U square by u is u. Integral of 1 by u is log of mod u. Log of mod u. Plus integral of u with respect to u. U square by 2. Plus a constant c. Finally substitute back for u. U is tan x. Log of mod tan x. Plus tan square x by 2. Hope I understand. Important step is how to start the problem. Multiply and divide by cos x. Sin by cos, tan. Cos cube into cos, cos power 4. 1 by cos power 4, secant power 4. Secant power 4 is secant square into secant square. Right? 1 secant square as it is. Another secant square, you change it to 1 plus tan square x using the identity. Then put substitution, u equal to tan x. You can write this as 1 plus u square by u. Secant square x into dx is du. Separate the terms. Numerator is sum of two terms. Separate the terms and then integrate. Integral of 1 by u, log of mod u. Integral of u with respect to u square by 2. Substitute back for u. Get the answer. Move on to the next one. Integral of cos 2x by cos x plus sin x the whole square. Here I shall use cos 2x in terms of both cos and sin because denominator contains both cos and sin. Let the integral be equal to I. Let I is equal to integral of cos 2x divided by cos x plus sin x the whole square. Right? Cos 2x as cos square x minus sin square x. Right? Cos 2x as what? Cos square x minus sin square x. Because denominator contains both cos and sin. Cos 2x, of course, there are four formulas. Cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, 1 minus tan square x by 1 plus tan square x. The suitable one here is cos square x minus sin square x because denominator contains both cos and sin. Hope you understand. Then you can split the numerator in the form of a square minus b square, which is a plus b into a minus b, correct? Then you can cancel one of the terms there. A square minus b square form, numerator, which is a plus b into a minus b. Cos x minus sin x into cos x plus sin x. Denominator cos x plus sin x the whole square. I can write it as cos x plus sin x into cos x plus sin x. Cos plus sin into cos plus sin. Cos plus sin is going to cancel. Correct? Cos x plus sin x will cancel. We can integrate this by simplifying it. Whenever you get expression of this type, cos minus sin by cos plus sin, we can divide numerator and denominator by cos. Cos by cos 1, sin by cos tan. Cos by cos 1, sin by cos tan. It becomes 1 minus tan x by 1 plus tan x, which is tan of pi by 4 minus x. We can integrate. Integral of tan, log of mod secant pi by 4 minus x divided by coefficient of x minus 1. That is one method. Another method is I can go by method of substitution, because if you differentiate the denominator, I get the numerator, correct? Derivative of sin is cos. Derivative of cos is minus sin. I'll go by method of substitution here. Put t equal to denominator. So that if you differentiate the denominator, I get the numerator. Put t equal to cos x plus sin x. Put t is equal to cos x plus sin x. Differentiate this. dt by dx. dt by dx, derivative of cos x minus sin x, derivative of sin x is cos x, which is cos x minus sin x. So dt is equal to, I'm getting cos x minus sin x into dx, cos x minus sin x into dx, correct? Cos x minus sin x into dx is dt. So this becomes integral of dt divided by t. dt means 1 dt, integral of 1 by t, log of mod t, log of mod t plus a constant c, that's equal to log of mod, what is the t you substitute by, t is cos x plus sin x. Correct? Simplify and get the answer. Cos 2x I wrote, cos square x minus sin square x. A square minus b square form, a plus b into a minus b. Denominator is cos x plus sin x the whole square, which is cos x plus sin x into cos x plus sin x. So these two will cancel. Integrate this by method of substitution as shown here. Put t equal to denominator. If we differentiate the denominator, we get the numerator. Derivative of cos x minus sin x. Derivative of sin x is cos x. Cos x minus sin x into dx is dt. Integral of dt by t is log of mod t. Substitute back for t finally to get the answer. And add a constant c for every indefinite integral. Move on to the next one. Take this integral as I. You can see inverse trigonometry function. So simplify this first and then integrate. Take the integral as I. Let I is equal to integral of sine inverse of cos x. Cos x could be written as sine of pi by 2 minus x. No conditions are given here. Correct? So this is sine inverse of cos x, we write sine of pi by 2 minus x. Cos x is sine of pi by 2 minus x. Sine inverse of sine of pi by 2 minus x is pi by 2 minus x. Assume that it lies in the principal branch. We assume that pi by 2 minus x lies in the principal branch. Integral of constant is constant into x. Integral of pi by 2 is pi by 2 into x. Integral of x is x square divided by 2 plus a constant c. Integral of constant is constant into x. Integral of x is x square by 2. Move on to the next one. Hope you understand. I wrote cos x as sine of pi by 2 minus x. Sine and cos are co-functions, the complementary functions, correct? Co-function using the allied angles concept. Sine of pi by 2 minus x is cos x. Sine inverse of sine of pi by 2 minus x, written as pi by 2 minus x. Assume that it lies in the principal branch of sine inverse, which is closed interval, minus pi by 2 to pi by 2. Integral of constant is constant into x. Integral of pi by 2 is pi by 2x. Integral of x, x square by 2. Finally, add a constant c for every indefinite integral. Move on to the next one. Integral of cos 2x by sin x plus cos x the whole square. I think this question is repeated, correct? Cos 2x, this question is repeated, okay? Can leave this because this question is same as the question number 25, okay? Cos 2x by cos x plus sin x the whole square. It's already done. No need to do this by mistake. It has been repeated. Move on to the next one, 28. Take this integral as I. It's given as multiple choice question as given in the NCERT book. I've taken it. So take the integral as I. Let I is equal to, separate the terms and integrate sin square x minus cos square x by sin square x cos square x. Sin square x minus cos square x divided by sin square x into cos square x. Separate the terms and then integrate. This is equal to sin square x divided by sin square x into cos square x. Sin square x divided by sin square x into cos square x with respect to x minus integral of cos square x divided by sin square x into cos square x. This becomes equal to sin square x will cancel here, correct? 1 by cos square x, which is secant square x, minus integral of, here cos square x will cancel, we get 1 by sin square x, which is cosecant square x. Integral of secant square x is tan x. Integral of cosecant square x is minus cot x. Correct? So we get the answer as tan x plus cot x plus c. Integral of secant square x is tan x. Integral of cosecant square x is minus cot x. Minus of minus plus. So tan x plus cot x plus c, which is option A. Simple one. Move on to the next one. Integral of tan square of 2x minus 3. To integrate tan square, we don't have direct formula. You should write secant square minus 1 as I told earlier. Let I is equal to integral of tan square of 2x minus 3. Tan square of 2x minus 3. Write tan square as secant square minus 1. This becomes integral of secant square of 2x minus 3 minus 1. Tan square, you write secant square minus 1. Correct? This is equal to integral of secant square is tan. Tan of 2x minus 3 divided by coefficient of x, that is 2. Integral of secant square is tan. Tan of 2x minus 3 divided by coefficient of x is 2. Integral of 1 is x plus a constant c. Integral of secant square is tan. Tan of 2x minus 3 divided by coefficient of x, which is 2. Correct? And integral of 1 is x plus c over. Simple question. Next one, integral of e power 2x plus 3. This we can write the answer directly. Integral of e power x, correct? E power 2x plus 3 divided by coefficient of x 2 plus c. Next one, integral of root of ax plus b. Take the integral as I. I is equal to integral of root of ax plus b. We know integral of root x. Integral of root x is 2 by 3 x power 3 by 2. Terms inside the square root is a linear term. So after integrating, you divide by coefficient of x. This takes the form integral of root x, which is 2 by 3 into ax plus b to the power 3 by 2. Correct? Whole thing is divided by coefficient of x, which is a, plus a constant c. After integrating, you divide by coefficient of x. Move on to the next one. Take this integral as I. Let I is equal to integral of x divided by e power x square is there. Now take it up. Take it to numerator. This becomes e power minus x square. To integrate this, I'll use method of substitution. Put t equal to x square because derivative of x square is 2x. Put t equal to x square. So dt by dx is equal to 2x. So from this I can write dt by 2 is equal to x into dx. dt by 2 is equal to x into dx. So x into dx is dt by 2. dt by 2 is half, keep outside. Half e power minus t dt. Correct? X into dx is dt by 2. dt by 2 means half dt. And this becomes e power minus t because x square is t, minus is there in the power. So e power minus t. Integral of e power minus t is e power minus t divided by coefficient of t, which is minus 1, plus a constant c. So answer is minus half into e power minus, what is the t you substitute back? T is x square, minus half e power minus x square plus c. Hope you understand. By using method of substitution, e power x square in the denominator, take it up, e power minus x square. Then use method of substitution and get the answer. Quite simple one. Integral of e power minus t is e power minus t divided by coefficient of t, which is minus 1. Next one, multiple choice question is given here. Take the integral as I. Let I is equal to integral of e power x into 1 plus x divided by cos square of x into e power x. Here we use the substitution here. If you differentiate x into e power x, no, I'll get the numerator. So put t equal to x into e power x. Put t is equal to x into e power x. Differentiate this by using product rule. dt by dx is equal to, applying product rule because it is multiplication of two functions. First function keep as it is. Derivative of e power x is e power x plus e power x into derivative of x is 1. E power x is common here. E power x common. So what remains is x plus 1. This is dt by dx or cross multiply this. We get dt is equal to e power x into x plus 1 dx. Numerator is dt. Correct? This becomes e power x into 1 plus x dx, that is dt, divided by denominator is cos square of t. Correct? Dt means 1 dt. 1 by cos square t is secant square t. So this becomes integral of secant square t dt. Integral of secant square is tan t plus c. Tan t plus c. So tan of, what is the t you substitute by? T is x into e power x plus c. Correct? This question was asked in the CET exam also in 2016. So tan of x into e power x, option B is the answer. 1 by cos square t secant square t. Integral of secant square is tan. Finally substitute back for t, which is x into e power x. Tan of x into e power x plus c. On to the next one. Integral of sin x into sin 2x into sin 3x. Product of three sine functions. Here use the transformation formula, the defactorization formula we have. Sin A sin B is equal to minus half cos A plus B minus cos A minus B. Take the integral as I. Let I is equal to integral of sin x into sin 2x into sin 3x. Use the defactorization formula here for this sin A sin B. Sin A sin B is equal to minus half into cos A plus B minus cos A minus B, cos of x plus 2x, that is 3x, minus cos of x minus 2x, that is minus x. This entire thing is multiplied to sin 3x. Correct? Sin A sin B formula, minus half into cos A plus B minus cos of A minus B, x minus 2x minus x. Cos of minus x is cos x. Then multiply this inside further. This is equal to minus half into integral of what we have, cos 3x into sin 3x. Cos 3x into sin 3x. And cos of minus x is cos x. So that you multiplied cos x into sin 3x. Here what we get, this is equal to, here cos theta sin theta formula. Cos theta sin theta is sin 2 theta by 2. I can use that formula. Here further use the transformation formula. Cos A sin B. Cos A sin B is half sin A plus B minus sin A minus B. Use that formula. This is sin 2 theta by 2. Correct? Sin theta cos theta. Cos theta sin theta. Angles are same. No? Angles are same means I can use the formula cos theta sin theta, which is sin 2 theta by 2. Correct? Because sin 2 theta is, we know, 2 sin theta cos theta. Sin 2 theta, we know this is equal to 2 sin theta cos theta. So cos theta into sin theta is sin 2 theta divided by 2. So this becomes equal to minus half into integral of This is equal to how much? Cos 3x sin 3x will be sin 6x divided by 2. Sin of 6x divided by 2 minus cos A sin B. Cos A sin B is half sin A plus B minus sin A minus B. Sin of A plus B 3x plus x 4x minus sin of A minus B x minus 3x, which is minus 2x. This much I need to integrate. Correct? So far I have not done integration. At this stage I can simplify one more step and then integrate. Here I use the formula cos A sin B. Cos A sin B is half sin A plus B minus sin A minus B. Correct? X plus 3x 4x. X minus 3x minus 2x is equal to minus half into integral of what we have, sin 6x by 2, sin 6x divided by 2 is there, no? This 2 and 2 denominator keep outside, we make it 1 by 4, that's better, correct? 1 by 4 I'll keep, that will be 1 by 4 here. This is minus 1 by 4 because this 2 and 2 taken common kept outside, 1 by 2 into 1 by 2, 1 by 4 minus sin 4x minus sin 4x. Here sin of minus 2x will be minus sin 2x, minus comes out, minus into minus plus, plus into minus again minus sin 2x. Sin of minus theta is minus sin theta, you must know that. Sin of minus theta is equal to minus sin theta. Now integrate this, is equal to minus 1 by 4 into integral of sin is minus cos 6x divided by 6. Integral of sin is minus cos, minus of minus becomes plus cos 4x divided by 4. Integral of sin is minus cos, minus of minus plus cos 2x divided by coefficient of x 2. Close the bracket. Finally add a constant c over. Hope you understand this. Integral of sin is minus cos 6x divided by coefficient of x. Integral of sin is minus cos, minus into minus plus cos 4x divided by coefficient of x4. Integral of sin is minus cos, minus of minus plus cos 2x divided by coefficient of x2. Correct? Move on to the next one. Hope you understand this. Here use the double angle formula, sin 2 theta by 2. Cos A sin B is half sin A plus B minus sin A minus B. Sin of minus 2x minus sin 2x. Minus into minus is minus. On to the next one. Question number 35. I think this is the last question of this session. Integral of 1 by cos x minus a into cos x minus b. See, there are different types of integrals of this type. I can show you all the techniques of simplifying and also writing the answer at one stretch. You can write the answer. This type of question was asked in KCET 2009 also. Same type of question. I'll explain all those things. Here, denominator contains both cos with different angles. The first angle is x minus a and the second angle is x minus b. 1 by cos into cos. 1 by cos a cos b I can call. So in this case, to reduce it to the standard form, what we do is you multiply and divide by sine of the second angle minus first angle. What is second angle minus first angle? See, second angle is x minus b. Second angle is x minus b. And the first angle is x minus a. What is the difference between the second angle and first angle? See, x will cancel, correct? Minus of minus becomes plus a minus b. So remember, whenever 1 by cos into cos is given, you multiply and divide by sine of the second angle minus first angle. So take the integral as I. I is equal to integral of 1 by cos x minus a into cos x minus b is there. Cos x minus a into cos x minus b dx. What we do is, you multiply and divide by sine of a minus b. Multiply and divide by sine of a minus b. Multiply and divide by sine of a minus b. This is cos of x minus a into cos of x minus b. And write this a minus b as the second angle minus first angle. See, a minus b is x minus b minus x minus a. That's the most important. Then I'll use the compound angle formula there. This is equal to 1 by sine of a minus b, 1 by sine of a minus b. A minus b is constant, so sine a minus b is a constant. Here numerator a minus b is the angle, no? There I'll write it as x minus b minus x minus a. Second angle minus first angle. There I'll use the compound angle formula. Correct? Sine of a minus b. The compound angle formula I'll apply. Sine a cos b minus cos a sin b here. Denominator is cos x minus a into cos x minus b. That you keep as it is. At this stage, we can expand using compound angle formula for the numerator. Then separate the terms. Okay? This is equal to 1 by sine a minus b, 1 by sine of a minus b, integral of, what is sine of a minus b here? Sine a cos b minus cos a sin b. Sine of x minus b into cos of x minus a minus cos of x minus b into sine of x minus a. Correct? Expanding it using the compound angle formula. Divided by what we have, cos of x minus a into cos of x minus b dx. Then separate the terms. Divide individually. Divide this by this, this by this. When you divide this by this, cos x minus a is going to cancel. Sin x minus b by cos x minus b, that is tan x minus b. So this is equal to 1 by sine of a minus b, 1 by sine of a minus b, integral of what we have. When you divide this by this, cos x minus a is going to cancel. Sin x minus b by cos x minus b is tan of x minus b. Minus, here when you divide this by this, cos x minus b is going to cancel. Sin x minus a by cos x minus a is tan of x minus a. This is equal to what we have, 1 by sine of a minus b, 1 by sine of a minus b into integral of tan, we know, log of what? Secant. Correct? Integral of this is log of mod secant x minus b divided by coefficient of x1. Integral of tan of x minus a, log of mod secant x minus a divided by coefficient of x1. So I'll get log of mod secant x minus b, log of mod secant x minus b, but divided by 1, correct? Minus log of mod secant x minus a divided by coefficient of x, that is 1. No need to write. Further, I can use the property here, log a minus log b, log a by b, correct? So I'll write here, I is equal to what we have, 1 by sine of a minus b, 1 by sine of a minus b, using the property of log here, log a minus log b, log a by b, log of mod secant x minus b by secant x minus a, log of mod secant x minus b divided by secant of x minus a plus a constant c. And also we can write this secant, you can take it up. Secant is 1 by cos and 1 by secant is cos. Correct? Secant is 1 by cos and 1 by secant is cos. Correct? So I can use that and simplify one more step. So this is equal to finally 1 by sine of a minus b, 1 by sine of a minus b into log of mod, this denominator secant, I'll take it to numerator, becomes cos of x minus a. This secant, you bring it to denominator, becomes cos. So cos of x minus b plus a constant c. Hope you understand. So writing way I'll teach you. I can write the answer at one stretch. No need to write all these things. So much of this. Okay. I'll write in the next slide, next page I shall write, and different integrals I'll take. Not only 1 by cos into cos. I'll take 1 by sine into sine, 1 by cos into sine, 1 by sine into cos. All I'll write at one stretch. Only in one step I'll write the answer. Suppose it is integral of, see the first one, integral of 1 by sine x minus a into sine x minus b is given. 1 by sine x minus a into sine x minus b is given. What is the answer? I'll write at one stretch. See, this is equal to. Because both are sine, no? Both are same function. If same functions are present in the denominator, 1 by sine into sine or 1 by cos into cos, when same functions are present in the denominator, you multiply and divide by sine of a minus b. So what we'll have is 1 by sine of a minus b, 1 by sine of a minus b, log of mod, okay, sine x minus a by sine x minus b over. How to write the answer? Learn the technique of writing this. Log of mod sine x minus a by sine x minus b over plus a constant c. Very simple. One stretch. The method, if you want, the same way as we did in the previous problem, same way you should do. Multiply and divide by sine of a minus b. Then sine of a minus b, you can write it as sine of x minus b minus x minus a. Okay. Remember, multiply and divide by sine of second angle minus first angle always. Okay, if same functions are present, you multiply and divide by sine of the second angle minus first angle. If different functions are present, you multiply and divide by cos of second angle minus first angle. That's the technique. Suppose you want to write integral of 1 by cos x minus a into sine x minus b. Cos x minus a into sine x minus b. How to do this? This is equal to, see, different functions are present, no? So multiply and divide by cos of the second angle minus first angle. That will be cos of a minus b. So I'll get 1 by cos of a minus b. 1 by cos of a minus b into log of mod cos x minus a by sin x minus b. Log of mod cos x minus a divided by sin x minus b. Useful technique to write, okay, answer in one step. One step you can write the answer. Hope you understand. If you want the method, no, you multiply and divide by cos of a minus b. And 1 by cos a minus b keep outside the integral because cos a minus b is a constant. And the numerator cos a minus b, write cos of x minus b minus x minus a. Then use cos of a minus b formula. Cos a cos b plus sin a sin b. Then separate the terms. Then integrate. You'll get the answer. One more I'll write. That is integral of 1 by sin x minus a into cos x minus b. 1 by sin x minus a into cos x minus b. Like this we have. Correct? This is equal to what? 1 by sin into cos. Correct? Different functions are there. So multiply and divide by cos of second angle minus first angle. That is 1 by cos of a minus b. Answer is 1 by cos of a minus b log of mod numerator by denominator. Numerator is first factor, and the denominator is second factor. Log of mod sin x minus a by cos x minus b over log of mod sin x minus a divided by cos x minus b. Hope you understood how to write the answer. And lastly, I'll complete that also, which I have solved that. Integral of 1 by cos x minus a into cos x minus b. If same functions are there, you multiply and divide by sin a minus b. If different functions are there, you multiply and divide by sin cos a minus b. Same functions means you multiply and divide by sin a minus b. If different functions are present, multiply and divide by cos a minus b. Same functions, no? Both are cos or both are sin. Same function means multiply and divide by sin. So 1 by sin a minus b, 1 by sin a minus b into log of mod cos x minus a divided by cos x minus b. You can try all these things, proof, okay. The last one I've done here, which is already present in the NCERT book. I solved this, okay, and I also explained how to do the other problems. For this integral, you multiply and divide by sine of a minus b. 1 by sine a minus b keep outside. Numerator sine a minus b, right? Sine of x minus b minus x minus a. Then use compound angle formula. Sine of a minus b. Sine a cos b minus cos a sine b. Then separate the terms. Divide individually. Then integrate. Okay, you'll get the answer. For this, different functions are there. So multiply and divide by cos of a minus b. 1 by cos a minus b, keep outside the integral. Numerator cos a minus b, write it as cos of x minus b minus x minus a. Then use compound angle formula, cos of a minus b, cos a cos b plus sin a sin b. Separate the terms, divide individually, then integrate. You'll get the answer. And use the property of log also at last. Here also different functions are there. So multiply and divide by cos of a minus b. Different function means multiply and divide by cos of the second angle minus first angle. If same functions are there, means both are cos or both are sine. In that case, multiply and divide by sine of the second angle minus first angle. Okay, this is a technique. So here you should multiply and divide by cos of a minus b. 1 by cos a minus b, keep outside. Numerator cos a minus b, write it as cos of x minus b minus x minus a. Then use cos of a minus b, cos a cos b plus sin a sin b. Separate the terms, integrate, use the property of log, get the answer. All these things very important for CET point of view. Okay, even for various competitive exams, these kind of questions can be asked. Okay, so quite important. Please learn all these things. Learn the way of writing it one step. Okay, with this I completed all the NCERT exercise 7.3, the integration by using trigonometric identities, and also given the techniques how to write the answer in one step only. This type of question was already asked in KCET 2009. Also this type of question is found in the NCERT book, correct? So it's quite important. So whatever there in the NCERT book, you have to master it first. Learn the formulas. Integration is not a difficult chapter at all. It's an easy chapter, okay? Please learn the formulas and practice all the problems. I completed all the problems of NCERT exercise 7.3 and also the solved examples connected to those exercises. Okay, I'll be uploading more and more videos in the coming days. Please subscribe to my channel, forward it to your friends. Okay, watch, and you'll get, definitely you'll be gaining knowledge by watching my video. Okay, the NCERT level also, if you are listening, it's well and good only. NCERT also, different people can teach in different ways, and I'll be imparting knowledge to all of you. Please subscribe to my channel. Okay, with this I'll conclude. Thank you.